Okay, so I wanted to start with something new today, the graphical user interface building. It will probably take a bit more time to get the tool that I need over here downloading, so maybe in the second half of the class I'll introduce that. But before we get there, let us cover some more OP stuff, object-oriented programming. We have done bits and pieces of this in our lab class and also in theory class. In lab class we implemented some more methods, not just the add one. So let me just এটাকে ইস্যু করছেন আচ্ছা কানেক্টর সেগমেন্ট শরীফে সে ইয়েতে কানেক্ট করার চেষ্টা করতেছে কেন না ওয়াইফাই কানেক্ট ওয়াইড কানেকশন আছে তার মধ্যে আবার এখানে যেতে চাই কেন
আচ্ছা স্যার ওয়াইফাই রাখাটা বেটার স্যার ওয়াইড দরকার নাই কারণ এখন আমরা ছাড়বে না আর কি 7 days বলবো আইপি রিফ্রেশ দিচ্ছি 7 দিন আগে ছাড়বে
কানেক্ট করা নেই তাহলে
যে লিমিট হিন্দি দেন
যাবে না তো দেয়
না
Wi-Fi network connected. Okay.
Wi-Fi
ওইটা ক্যান্সেল করে দিন।
না ক্যান্সেলের জন্য সবাই কি পাচ্ছে
না না সেটা কিন্তু এখন তো ফোনে ডাবল ডেভেলপ নেই।
60 দিয়ে আসলাম
Okay, sorry about that interruption. So in the last class we added some more methods, particularly about the rational number, but in the complex number I asked you guys to look up the operation, how it's done, and then implement that by yourself. Did you guys try it, or if someone had any problems? Nothing? Okay, alright, so I'll assume that you guys can do these things. I mean, whatever we cover in class or whatever I give you as homework, they're up for the midterm or final exam questions, so please do the homeworks at home. Or if you find any problem with them, let me know so that we can discuss them again. Now, in today's class, I wanted to start with another example. But before going into the example, I mean, this is still going to be about object-oriented programming, but some more concepts about that. Let me use Dia over here. And I'll also need the journal to write a few things down. So what I want to do here today is I want to talk about bank accounts. Okay. Are we all familiar with bank accounts? Do we all have bank accounts? No? How many of you guys got bank accounts? Right. A few of you do have bank accounts. But even if you don't have bank accounts, the concept of bank accounts is, I think, very common to you guys. Like we store our money in the bank and we can withdraw them. Right? See, the act of storing money is called deposit, and the act of pulling it out or taking it away from the bank is called withdraw. Withdraw and deposit, these are the two most common things that we do to the bank accounts. Now, why do we want to keep our money with the bank, not to ourselves? Yeah, safety is one big concern, right? And what else? You can get some benefits. Okay. What sort of benefits? You can get interest. If it's not, if it's about Islamic banking, then you don't get interest. You get something else. You get return on investment, which is called mudaraba. So the idea of getting more money than what you have already is already there. If you don't want to invest it by yourself, then you leave it on the bank, that use it for some business so that I can get more money out of it. And that's why we keep money in the bank. Okay. So why the bank can give us more money than what I put in is the bank itself can invest in many other things. Bank can finance a lot of things. Bank can also give out loans at personal level or at business level, and when people give the money back, they pay it with interest. That's why bank can afford to give us some more money. So that's the banking model that we are used to. Now, when you go and open up a bank account, there are many variants of bank accounts, and they work differently. So let me talk about a few of those. Yeah, I'll add that student account as well. Okay. Bank accounts, they can take many different forms. We can have a current account, which is used for day-to-day activities. You can deposit money whenever you want. Well, actually, you can deposit money to any of these accounts whenever you want. Bank will never say no, right? Because they're getting money. But when it comes to taking out money from the current account, the idea is that you'll be doing it a lot of times. That's why bank will not get any chance to invest it anywhere. That's why they're not going to give you any return based on that. And you can imagine the same sort of scenario. I mean, this is very common in Dhaka now. There are many ATMs all throughout the city. So what happens in the ATM? People can walk in, use their cards and the PIN number, and they can take out money. The money is actually being stored inside the machine every single day. Okay? Hundreds and thousands of times, because like you can think about just yourself, like if you may have 20,000 taka as the withdrawal limit, but there are many different people who have the same limit. Now, it is very common that not everyone is going to go and withdraw money, but then the bank at least has to make provision so that sufficient number of people will be able to withdraw money from there. So somewhere around 5 or 6 taka in each machine is very much common, that you leave that money there. And that also means that it's not getting invested. Okay. So if you're going to withdraw money and the money needs to be kept in ATMs where it cannot be invested into any business, you're not going to be able to give anything in return to the customer. But this is a very important service to the clients because they don't have to go to the bank to withdraw money. And the concept of ATM is nothing really new. Even if you go to the bank and withdraw money, it's the same story. Bank has to keep the money to them because you can go to the bank at some point in time, like within office hours. The advantage of ATM is that you don't have to maintain any office hours. You can go there at midnight and withdraw money. But if you went to the bank within the office hours, then you could withdraw money, right? So the bank had to keep some money in their branch so that they can give out cash. And these are money that they cannot invest in any other place. They have to keep it handy because someone can come over here. The idea of this current account then is about withdrawing money regularly. If you do that regularly, then the bank cannot invest your money in anywhere, so they will give you zero interest. What they will do in addition to that is they will charge you money every time you withdraw. Okay, so that they're trying to discourage, do not withdraw so much money because that puts me at a disadvantage. Withdraw less so that I can invest it somewhere. That's the total story. So you may be familiar with this already. Like if you use a different ATM than what your bank has, then you'd have to pay extra. So for example, I have a Dhaka Bank card. If I go into Bragg Bank, if I withdraw money, maybe I'll have to pay 15 extra per transaction every time I withdraw. So these are things that they put in place to discourage people from withdrawing money. Savings account, on the other hand, is created on the premise that you're going to keep the money, you're going to save the money for some later investment. That means that the money will be with the bank for a longer period. Okay? So on a savings account, you may find that they're going to give you like 5 to 7% interest, or it may vary depending on the plan, depending on the bank itself. Okay? If you go into fixed deposit, then bank gets more sort of guarantee that the money is going to be there. They're going to give you a higher rate of return. And an example of fixed deposit can be 5 years long Sanchoy Patra, like that government sells. You can buy that, you get high interest at the end of the period. You're not going to get anything in between. I mean, that's the idea. You're going to get all the money right at the end. If you want to withdraw money in the middle, yes, you can do that, but you get reduced amount of interest, reduced amount of return for that. Student account, well, they're primarily used for students to pay their fees, the tuition fees. They can also use it to save some money. In foreign countries, student account can also mean that they can take loan from the bank for their tuition fees, and when they get a job, they're going to repay that. So that's the idea of student account. I think some university of Bangladesh have already started this, giving students loan on some basis, and they can repay that back. Credit card, they are very popular these days. You don't have to carry cash with you. You can pay money with your credit card. But this is a somewhat different scenario compared to these things, the credit card. Why is it different? because you're not paying out money from your pocket, you're going to pay out money from the bank's pocket. You don't have to have the money, you're paying on credit. Just excuse me a bit. Hello. Could be Rexy. না 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 ওই 19-20 21.2 20.3 হ্যাঁ আগেটাই চলতেছে মানে ওই আগের জিনিসটা আরেকবার ডাউনলোড করতে দিছি তো ফেল হলো না আগেরটা এই মুহূর্তে আবার দেইনি আমি কি আরেকবার ক্যান্সেল করে দিতে বলতেছেন তাহলে হ্যাঁ আর দেখাতে চাইছিলাম এখন তো মনে হচ্ছে না পারবো আমি আরেকবার দিচ্ছি ক্যান্সেল করে আরেকবার দিচ্ছি পেজ লোড একই রকম স্লোই আছে আর কি হ্যাঁ ডাউনলোড দিলাম আমি না আসলে একই রকমই 25-23 নামতেছে আর কি 22-31-32 মিনিট দেখাচ্ছে Sorry about that interruption again. The credit card, I was talking about it. It's a different thing because a bank is paying on your behalf and you pay the money back to the bank at the end of the month. So you get like 30 to 40 days to pay your money back. But in the meantime, you don't have to have the money with you. So that's again a different scenario in how the whole thing works. What you do have in common in all these things is that you have the same sort of operations. With all these bank accounts, you can deposit money, you can withdraw money. This thing is common to everything. Even if you talk about the credit card, every time you make a purchase, you're not actually withdrawing cash, but you're actually withdrawing money from your credit card. So that's more of a withdrawal operation. When you pay your bills by paying the bank, that's actually when you deposit money. Okay. So even credit card has the notion of withdraw and deposit. This current account has the notion of withdraw and deposit. The same goes for savings account, same goes for fixed deposit and everything. So the same set of operation is there. Okay. But internally, they will work differently. Internally, you'd have something called a balance for your current account. Whatever money you have is your balance, right? That's the amount of money I have. If I try to withdraw more money than the balance, can I do that? No. Usually the answer is straightforward no. If you don't have the money in your bank, why is the bank going to allow you to withdraw more money? They won't. Okay? However, if you're a known client, if you're a big business, the bank will allow you to withdraw more money. You have written a check. They will honor that. But they will mark your account as overdraft, they will send you messages, they may impose a fine on your account. Okay? That's a different story. But in regular scenario, you cannot withdraw more money than what you have. If you look at the credit card, do you have the same sort of idea for withdrawal? There is a totally different scenario over here in terms of credit card. What we do have is called a credit limit. So let's say you have a 50,000 taka credit limit on a card. You cannot make purchases of more than 50,000 taka with that. Let's say I bought a freeze worth like 40,000 taka, so I can make 10,000 taka more purchases based on credit. Okay? I can pay some of it back by depositing some money, then I will have regained that thing, that amount that I can do some more purchases. So internally, the current account withdraw method, it checks against your current balance, whether you have the balance to withdraw. If you're going for the credit card, do I do the same thing? No. I check against my credit limit and whatever I have purchased till now. So based on that, I mean, still the same name, it's the withdrawal thing, but they work differently. Okay? So this is what I want to get to today, that there may be similar sort of concept, but they work differently internally. How do we model those things in our Java program, or how do we even design them? Another thing you need to understand is, I mean, that's about the operation. What about the information? What sort of information do we store for each of these bank accounts? Anytime you go and try to open up a bank account, they will give you like a 4-page form. Okay? They'll ask you your name, your address, your phone number, your father's name, your mother's name, and even if your dog's name, if that's possible. And you have to provide a lot of information just to open a bank account. You need to provide your national ID. If you have a passport, you have to provide that. Your taxpayer's identification number, you have to provide that. So there's a lot of information to fill in every time you open up a bank account. Some of these things are just text, some of these things are numbers, some of these things are something totally different. For example, you have to provide your picture. That's a different sort of information. You have to give a specimen signature, which is again another picture. In future, we may have to provide some sort of biometric information. Let's say a fingerprint scan. That again is a different sort of information that you need to provide for the bank account. But all these things, these are attributes. What's my account number? That's an attribute. What's my account name? That's another attribute. The balance, how much money I have in my bank account, that's an attribute. For credit card, the credit limit, that's another attribute. So all these things are attribute. The operations like withdraw, deposit, those are operations. And that tells us that we can actually create data type for bank accounts. So let us work with a very simple bank account model. In real life, things are going to be much more complicated, but we're not going to go for that right now. We are going to create a class, a very simple bank account class, right? I can't write space in between because that's not allowed in Java or in C or in C++. These identifiers, the names, they cannot have spaces in between. In Java, by convention, whenever you're writing a class, the first letter has to be in uppercase. If the name has multiple words, every word should start with a uppercase letter. Okay? Following these conventions are quite important. Your program will compile even if you don't follow them, but people will find it difficult to follow. So let us just maintain this practice all around. So we have given the class name, and now it's the time to get some attributes in place. Let's say we have a account ID, which is going to be a number. Let's say we store it as long. And since this is about data, we have talked about encapsulation before. We want to keep our data secure, right? So we go for private access. And we're going to follow this all throughout the course, barring from some minor changes, that every time we declare the attributes, we're going to mark them as private. It's a good practice. There are scenarios where you'd have public members, but I will show you where that's applicable. And there are also scenarios where you'd want to have private operations. But unless otherwise specified, every time you do some attributes, they're going to be private. All the operations, they're going to be public. So plus over here, minus over here. Okay? And I'll mention the scenarios where things are going to change. So we got the account ID. Let's say we got a name for the account, which is going to be string, the name of the account owner, and this is very important, the balance, how much money you have in your account. Okay, and let us get one more string. Okay, the address as string, that's also there. Okay, so these are the attributes. In real life, definitely you'd have tons more of attributes. Your passport number, your national ID number, all these things, they will be there. Okay, so as for the operation, I'll go with something very simple for now. Let's say we have a withdraw method through which you can take out money from your bank account. The parameter that you need to pass with the withdrawal method, what should it be? Why do we need to pass any parameter to withdraw?
Reduce the balance.
Total balance is also
Well, yeah, that's the condition, and yes, we want to reduce the balance. But I mean, what sort of information we need to provide right over here to the withdrawal method?
Current balance, about withdrawal balance.
Okay, all right. So the first thing that he mentioned, we won't have to provide that because that's already kept as an attribute, the current balance. But the other thing that you mentioned is quite important. How much money you're going to withdraw, that is something you have to tell. If you walk into the bank and you say, I want to withdraw money, they're not going to give you anything, right? You have to say, I want to withdraw 1,000 taka or 500 taka, whatever it is, right? You have to be specific that this is the amount of money I want to withdraw. And that's something we need to pass as parameter. So over here, in the parameter box, I'm going to write down amount, the amount I want to withdraw. What's going to be the type? Well, long or double, yeah, both are valid. Let me go with long. The reason that I left balance as double is that there can be some charges, there can be interest calculation that would bring in fraction numbers. But when you're trying to withdraw money, I mean, there were days where fractional amounts were important. You'd have coins worth 50 paisa or 25 paisa. There were time, and probably before you were born. But nowadays, I mean, it's even hard to get 1 taka note, or 1 taka coins, 2 taka coins, right? So, if you're trying to withdraw money, there's very little chance that you want to withdraw 1,000.50 taka. Maybe you're not going to do that. And bank wouldn't even allow you to do that. So let's say that we are going to go with integer amount, a whole number for withdrawing. So that's the amount we're going to withdraw. Are we going to give any return type to this method? Okay. When we withdraw money from our bank, what do we get in return? The remaining balance is already there in the attributes that will get auto-updated. I'm not going to get that. I mean, physically speaking, in real life what happens is that when you withdraw money, you get the cash in return. But it's not like that the computer is printing out cash for you. Okay? So it's not done that way. So we're not going to return anything. And let us leave it as void. What we can do is we can, if we want to, we can add a Boolean return type to say whether the withdrawal was successful or not. Okay. Sometimes when you try to withdraw from the ATM, it can fail. I mean, after you enter everything, it can fail. Maybe they don't have enough cash. Or maybe there are some network issues. So if the withdrawal operation fails, you need to know that. And that's when a Boolean type can make sense. So here's the thing, like, I mean, this is optional. You can return a Boolean thing, and I'm going to go with that. I'll show you that you can indicate that there is something wrong with Boolean, but that's also a valid design not to return anything and handle the errors in a different way. So both are okay. So we have this withdraw method, and we have a very important deposit method. And in the same logic, we're going to allow a Boolean return type. If your deposit method was successful, you return true, otherwise you return false. That's how it's going to go. The parameter to this thing is again going to be an amount that you're going to deposit. How much money you're going to deposit, you have to tell the bank. So that's the parameter. We need a few more things. All right, we need what else? We need get account ID. That would give us the account ID for a particular account. We need get address to get the address. Okay, I'm not going to write them all down. Let me just write down some of them. Get address should be a string. Okay. As for the set thing, we have talked about the getter methods and the setter methods, right? Get methods let you get the value, read the value. Setter methods allow you to change the value, update the value. So for address, for example, you'd want to provide a set address method that doesn't really return anything, but you have to pass the address as a string parameter so that you can change the address. Okay. So all these things, these are important, and I left out a very important get method over here. That's the get balance. I want to know what's my balance. Many times we walk into the ATM not to withdraw money, but to know how much money we got. Okay, so you can get a mini statement out from there. Okay. So I haven't written all these methods that I need. If you're going to do it professionally in real life scenario, if you're working in a farm, software farm, you're going to write down each and every method that are needed in that class. You're not going to leave them out. But since I'm demonstrating these things in class, I'm going to leave some of them out, and they're kind of obvious. So the get address, the set address I have introduced, and let me write down a print method which we will change later on. This print method simply prints out account related information on the console. Okay, we need a constructor, so let us make provision for that. The name of the constructor is going to be bank account. What are the things you need to pass when you create a bank account? Well, we need to pass the account ID, which is of type long. We need account name, which is of type string. We need the address, that's a string, and what is going to be the opening balance, how much money you're going to open this account with. Okay, so with that done, let me zoom it up a little bit. You can see that we have created, what is this? Now the whole thing, what is this diagram called? UML class diagram. We have created a UML class diagram for bank account. Here we got the attributes, here we got the operations. Okay, and altogether this is a UML class diagram. Now based on a class diagram, we can write a class. Okay. It's not going to give you the inner logics, that's up to you as a developer, but this is something we designed before we start coding. So in this example, in this bank account example, this is the basic scenario. Okay. We will fill it in, like how the balance is going to update, only through two things, withdraw and deposit. That brings us to our previous talk, that encapsulation ensures this. With encapsulation, you can say exactly how your data will change, how they will be accessed. Okay. It's not going to change randomly. So let me start a new project right up here, and let me just check how we're doing for the download. It's going to take ages, I think. Yeah, 30 more minutes. So I'm going to go with a new project altogether because it's a new concept, and we're going to go with a console application for now, a simple Java application, and this is going to be called, let's say, bank account demo. All right, so we have this bank account demo. And this is where I want to create a new file. If you press that white plus thing, this is going to be a Java class. The name of the class is bank account. And right over here, what we can see in this diagram, let me try to put it over here. Is that we have all these attributes. Okay, those attributes are listed over there. So within this bank account class, we can write down these attributes. We need a long account ID. We need string account name. We need string address and double balance. So once you have them in place, okay, I haven't written private in front of them. Okay, we can get NetBeans to write the methods for us. The get methods, the set methods, constructor, at least those things. The withdraw and deposit, NetBeans won't know anything about them. But the get methods are obvious, the set methods are obvious, so we can have them written. So let me start with the constructor because that's the most important, that's the starting point really. And these are the 4 parameters that I want in there. So I put check marks against them, I hit generate, and that will write the constructor for me. So you see we are passing 4 parameters, and it's kind of obvious how you create this constructor. Whatever you're passing, like the account ID, goes to the account ID over here. Okay. Next comes the get methods. So we go for the getter, and we want get method, let's say for everything, right? We want to know the information. So that's that. And here is this option down there. It says encapsulate fields. It's related to our OOP concept, encapsulation. When we say encapsulate fields, it really means that make them private, so that no one can access them from outside. So we say encapsulate fields, and then hit generate. You see, now they're all written with private. And as far as the method goes, they're very simple methods. You just return the value. So get balance, return balance. Get address, that's just return the address. Now you need one set method. We can easily get that. Alter insert setter methods. Maybe we want to change the address. So we hit generate, and there's this method for set address. You may think that the address may change. That's why we have a set address method. And so can the balance change, right? The balance will continuously be updated. So why not have a set method? What could be the reason?
Because they are dependent on the deposit and withdraw.
Yes, exactly. The updating of the balance thing, how this thing changes, is totally dependent on deposit and withdraw. If you provide a set balance method, that would allow the user of this system to randomly change the balance. So let's say I got 100 taka as opening balance. I can make it 1 million taka if I want to. I just say set balance 1 million, and that will change without actually depositing that 1 million taka in the bank. Okay, so we don't want that to happen. We want to have security in place. We want to keep our data secure. It's only going to change exactly the way it's supposed to change. Okay, let's say we get our CGPA based on all the courses, all the grades that we got. Okay, and just because I don't like my CGPA, let's say it's hovering around 2.8, I don't like that, I want to make it 4 out of 4, I can do that. There shouldn't be a set CGPA method. You have to earn the grade and then you get that. So this gives us more control. We don't have that control in C. That's not object-oriented programming. Here in OP languages, in C++, in Java, you have that feature that you can properly encapsulate those fields. You cannot change them unless you really want them to change, and you change them in a way that they're meant to be changed. So with that, we're almost set, except for the important ones. The deposit, withdraw, these two methods. Okay, these are custom methods that NetBeans cannot write. So let us get down to it. Let me write them over here so that we can see the whole thing. So the withdraw method, as you can see from here, the withdraw method takes a parameter and it returns Boolean. Let us start with that. Public Boolean withdraw, and here we're supposed to pass the long amount, how much we want to withdraw from the bank. Okay. So what happens when people withdraw money? Let's say okay, that's a very simple question that I'm laying out for you. So let's say our balance right now, or the opening balance was 1,000 taka, and we withdraw 600 taka from there. What's going to happen then?
It will make the balance 400.
We will update the balance, so we will have 400 taka remaining, and that's what we will have in the balance. So in other words, in terms of programming, can we say our new balance will be equal to our previous balance minus the withdraw amount? But there is nothing called new balance, it's the same thing. So we say balance equal to whatever the balance was minus this amount. Okay. And once this is successful, what are we going to say? We are going to return true, because this is how the method would work. It returns Boolean depending on whether the method the withdraw operation was successful or not. So right now we want to say yes, the withdraw method was successful because the amount was deducted. What can be the scenario where this withdraw method fails?
When the withdrawal amount is more than the balance.
Yes, when we try to withdraw more money than what we have. So even in this example, let's say I got 1,000 taka in my bank and I want to withdraw 6,000 taka. What's going to happen? Will I have like minus 5,000 taka in my bank? No, that's not going to happen. So before doing this, I want to check if my amount is less than or equal to my balance. Only then I can allow this to happen. Okay? If the amount is less than or equal to balance, then only this thing can happen. Otherwise, it will fail because I don't have the money. Right? Now, I'm going to fix the formatting, but let me show you a shortcut. See, right now I've written if-else, and it would look much better if I have this indented, if I have this moved to the right. That gives you a visual cue that this is inside the if part. And it's your responsibility as a programmer to make your code stand out like that. Alter Shift F. That's a shortcut in NetBeans. You can use that to auto-format your code. So if you have formatting issues, it will line up things properly. And that looks better. Alter Shift F. Okay, so that's that. And if this is not the scenario, else we return false, right? The withdraw method was not successful. But when you return false like that, you should also provide some sort of error message that this is what happened. So we can say system.out.printf, you do not have sufficient balance. Okay, where's my deletes? All right. So we can print out that message on our console, and that tells us what went wrong. Do I have to add anything else over here? Any other check?
Current
The current amount is given in terms of balance. If you try to withdraw more money than what you have, yes, definitely it's not going to work. What if you try to withdraw negative amount? What's going to happen then? The way this is written, let us try this out. Let's say we got 1,000 taka in our bank and we try to withdraw minus 6,000 taka. Okay. Is minus 6,000 less than our balance? It's a negative number. It's definitely less than 1,000, right? So this would pass. What's going to happen here? Balance was previously 1,000. You do minus 6,000, which is 1,000 plus 6,000. So your new balance is going to be 7,000, 1,000 taka plus 6,000 taka is 7,000. So if you allow people to withdraw negative amount, that's actually going to increase their balance instead of decreasing it. Okay, so what do? We check for this again. So that's one condition. Amount has to be less than or equal to balance, and amount has to be greater than 0. Okay. There's no point allowing the user to withdraw 0 amount. So anything greater than 0 is going to be fine. Okay, here's an easy homework. I want you to try this out. I want you to modify this so that you can only withdraw money in multiples of 500. That's what happens in ATMs. If you want to withdraw 510 taka, they won't do that. It has to be 500 taka or 1,000 taka, or even, let's say, 15,500 taka. That's possible. A customer amount. But it has to be multiple of 500. So here you're going to test it whether the amount that I've typed in is a multiple of 500 or not. It's going to be a simple check. One thing you would notice in ATMs, you have a number pad, right, where you can enter the PIN code, or you can use that to enter the custom amount that you want to withdraw. There is no minus sign. So this check doesn't have to be in there. You can't even try that. But it's always a good practice to write your code in a way that all the checks are in place, so that even if you're working with the ATM or working with any other system, in the actual server side, these things are properly working. Okay. So we have written this withdraw method, and before writing the deposit method, I want to test this out, whether this withdraw method is working properly or not. Okay. There is a very nice way of testing your code. Every little method that you add in your Java code, there is a very nice way of testing that. We call them testing frameworks. If I get a chance, I'll show you how JUnit test framework works. But that's a little bit advanced thing, so I'm going to do it further down the course, not right now. Okay. So we'll do it in our old-fashioned way. How so? Like we're going to create a very simple bank account. So let's say we created a bank account. Let me just call it B or B1. New bank account. And over here, we need to provide some sort of ID. Let's say that's the ID. And we have to give it a name, right? The address goes here. And also the opening balance. So let's say our Rajan Vardhan sir has opened a new bank account. And the opening balance is 5,000 taka. Okay. Now we can perform some operations like B1.withdraw. We can withdraw money, right? We can withdraw, let's say, 1,000 taka. And to test it out, if this thing works properly, it should print out the new balance as how much? 4,000 taka, right? So we can say system.out.printf current balance %if, because that's a floating point number. And over here we can say b1 dot get balance, so we can get the balance and we can print it out. Right, so we got 4,000 taka, and it seems that it's working properly, but we need to try it out with some other numbers and see if that's what we get. And while we're at it, I want to change a few things. Like if I want to print over here, I have to call the get balance. I have to, if I want to print the ID, the name and the address, I have to modify this thing. And if I want to do that again, I'd have to write this line over and over again, which is a little bit tedious. Rather than doing so, if you look at this thing, so if you're over here, see there's this print method. It doesn't return us anything, but it will print the information about the bank account to the console. So let us go into the bank account. We don't have this method yet, but we can write it out. It is going to be a simple method at that. Public void print. And this is where we want to say system.out.printf. Let's say I want to print the ID. That's going to be a long. I want to print the name of the account. That's a string. And I also want to print the balance. Let's say I want to ignore the address for now. So the balance, if I want to keep 2 digits after the dot, this is what I do. 2f. And this is where we can pass the account ID, account name, and balance. Are you guys with me so far? So within this bank account demo now, this is much simpler. I can just say b1.print. So it says ID 2331, name Rajan Vardhan, and the balance is 4,000 taka. Okay. So let us take another example. So if we copy this, let us create another bank account. Okay, and let us create another account for, I don't know, for our Ashik sir, and he lives in Notun Bazar. And let's say he's opening up a bank account with 6,000 taka in the bank. Okay, and I want to print B1, and I also want to print B2. So things are much easier because now I have a print method. I don't have to write everything, that print the ID, print the name, and print the balance. It will be all done through the print method. And if I make changes in the print method, it will change for both these things. So when we run this thing, you can see that the balance for Adenworton changes because we do a withdraw operation. The balance for Ashikur Rahman doesn't change because there is no withdraw call. Okay, is this setup clear? How we have it so far? So let us test this out. Let's say we want to call b2.withdraw, and this time around I want to withdraw 10,000 taka, although I have only 6,000 taka in the account. What does it say? It says 6,000 taka, so nothing really happened. What did happen? It said you do not have sufficient balance. Okay. Now that's an error message. It should look a little bit different from regular messages. And Java allows you to do so that if it's a regular output, you send it out through the system.out channel. We read through system.in, we produce output to system.out. However, if it's error messages, then it's not supposed to go into the output channel. It should go into a separate channel called R, ERR. That's for error. C, C++, they also have the same thing. If you're using C++, that's called CR, Cout, CR, and Cin. And you see that just by making that change, this thing is now printing it out in red. So that also gives you a visual cue. But more importantly, you can, when you write your program, you can send the output of all these error messages to a different file. That's what we do when we create logs. When we create system logs, whenever something goes wrong, or anytime you want to store some information, you can send that out into a log file as error messages, or it can be information as well. Okay, so are we okay with this thing? The withdraw method, and we got the print method in here. So let us just write the deposit method, because this is going to be very simple. Public boolean deposit long amount. All right. So what happens when you deposit money?
Increases the balance.
Yes, it increases the balance. So the heart of this thing is balance equal to balance plus amount. Just like the withdraw method, it reduces the balance. Balance equal to balance minus amount. This deposit method, it should increase the balance. So balance equal to balance plus amount. That's right. Okay. And once the deposit method is successful, we'd say that we return true. Okay. What are the things that can go wrong?
Negative deposit.
Yeah, negative deposit. Otherwise, we don't have anything to check. If you're going to deposit a lot of money, who am I to complain, right? The bank will be happy. The more money you're going to deposit, the happier I get. So the only thing we'd probably check is if you're entering negative amount. So if amount is greater than 0, then that's fine. Do this deposit. And also return true from there. Alt Shift F will fix that. Otherwise, system.r.println okay, some sort of error message over here, and we will say return false. Is this thing clear? We can add more money now, and we're certainly not going to allow negative numbers. So for example, B1 dot deposit, we can deposit 5,000 taka more into B1's account, and for B2, before withdrawing 10,000 taka, now if we say deposit, say 5,000 taka again, that'll do. See, this says where I got a compiler because I missed a semicolon. Now things would be okay. Is it correct, the balance? So for Ashik sir, previously we had 6,000 taka because the withdrawal failed. But this time around, there is no error messages. The withdrawal is successful because initially I had 6,000 taka, but before withdrawing, I deposited 5,000 taka more. So that brings up the balance to 11,000 taka, and you take out 10,000 taka from there, which is no big deal. So that's why this thing works. Okay. So if this example is clear to you guys, then we can expand from here to go into our new methods, our new data types rather. Okay, so this is the example of bank account, a plain vanilla bank account. Nothing fancy in here. Okay. For credit card, for savings account, for the current account, everything will be different. And they will have their own set of rules, and we will have to work accordingly. So let us make some assumptions. I mean, I'm not going to say that the banks in Bangladesh work in this way. Let us just imagine a new bank, right? We're going to set up a new bank. They have their own set of rules, and we're going to write code in that way. So let's say alright, so for current account, let us try to penalize the account holders. If they're going to withdraw, they're going to pay 15 taka extra as service charge or something as such. Okay, so we're going to bring that in. Now, if you are going to create a current account with this new set of rules, it's a new data type, right? We have a bank account where we have defined exactly how the withdrawal method works, how the deposit method works, how the get methods and the set methods work. We've all defined that. Now we come up with a new data type where the rules are a little bit different. What's the difference? Previously, in the general bank account, the withdraw says if you have sufficient amount in your bank, you can withdraw that unless you're giving us negative amount. See, the logic is already in place. If you look at this withdraw method in the bank account class, if you look at this, we have implemented this logic that if you have sufficient amount in your bank balance, and if this amount is not a negative number, then you can take out the money. How much are we deducting from the balance? The amount, right? However, if you're going to use our current accounts model, it's going to be very similar, but it's going to be different. Because after every transaction, we're going to lose 15 taka extra. Our balance will lose that amount. Yes. Additionally, we will lose 15 taka. So this is not the same, right? There is a very slight change. Okay. So if I'm going to create a new bank account like this, but that's for the current account, what I can do is I can create a new data type. So over here, we have this bank account. What we can do is we can create a duplicate of that and call this current account. Is it going to be any different? Everything that I have over here will be still the same, and at a design level, the name over here, withdraw amount of long type and the return type of Boolean, that's also not going to change. So this is again going to be the same. So if you look at the design, nothing's changing. In the implementation level, yes, there is a slight change in one method, in this withdraw method, but not in other places. Okay? So based on this design, if I'm going to write a new class, how can I do that? Just as I have done before, go into NetBeans. This is in always on top. This is set to be. Okay. So what I can do is I can create a Java class, call this current account, and pretty much follow the same sort of things. I declare those 4 attributes, create a constructor, and then write the methods and everything, right? We can redo that. Since I have mastered the art of copy and pasting, I can just go over here, select this thing, and paste it over here. I would still need to change a few things. For example, the constructor's name. Okay, that should change. The withdraw method itself, it should also change. Every time you withdraw, you should withdraw that amount, and you should also have sufficient amount in bank. Right? So you have to make those 2 changes. And once that's done, you can go over here and create a new bank account. I don't know where he lives. So wherever, right? So let's say he opens up a bank account with 1,000 taka, and let's say we deposit 1,000 taka, and then we withdraw 500 taka over here, and then we print this out. The balance says 1,500 taka, which is not what I expected, right? That's because I made a huge mistake. This is not supposed to be a bank account. This is supposed to be a current account on both sides. Now it's behaving properly, right? See, the problem right now, we got a bank account class, we got a current account class, they look pretty much the same. Just with some minor changes. But we have to create a new thing. We have to create this new class, we have to write all this code. And I'll just claim that I wrote all this code, which I didn't, I just copy pasted. It's still some sort of work. And if I make some changes to bank account, and I want the same changes over here, I'd have to come over here and make those changes. What sort of changes? For example, let's say I want to change the print method. Let me do that. Let's say we decided that right now we are printing the ID, the name, and the balance, but our new requirement is that we want to print the address as well. So we can write it over here, right? Print the account ID, account name, and then print the address, and then the balance. So if you run your code now, what do we see? We see the address for the bank account. Do we see it over here? No. Why not? Because our current account, the print method, it doesn't have the address in it. So that's me demonstrating that if you make some changes to the bank account, it doesn't get automatically copy pasted. Okay. Although maybe this is what you wanted because they're the same thing. A current account is a bank account with some minor changes. Okay. We're pretty much at the end of the class, so I'm not going to start this topic. But what we are going towards, let me leave it as a homework. We're going for a OOP concept called inheritance, okay? And that's what I want to go to. That if we created this current account class in a special way, saying that current account inherits from bank account, we wouldn't have to write all this code. It will be very simple code, only a few lines, not this entire thing. And anytime you make any changes, it will get inherited, so your code gets updated that way. The advantage of inheritance then is in code reuse. You can reuse the code. We talked about another OOP concept, which is called encapsulation. The advantage of that is keeping your data secure. Okay, we need to know why we use all these things. Okay, so that's where I'm going to stop, and I'll upload the code and everything. Did you guys sign the attendance sheet? Okay, it's there. All right then. Thank you guys.